This is our final video for section 1.2, talking about quantitative data and how we display it. So far we've talked about two methods of displaying quantitative data, our stem plots as well as our dot plots. Now, a graph of the distribution may be clear if things are grouped together, which you don't always see in stem plots or dot plots. So the most common graph of quantitative variables is in fact a histogram. Histograms and bar graphs are different things. We'll talk about that here in a little bit. So we're going to talk about how you make a histogram if you're just given the raw data. So first thing that you want to do is you're going to divide the range of the data into classes of equal width. Unless a problem states how many classes you should have, it's up to you what you decide. I would never go with less than 5 or 6. The more, the better, simply because it will give you a better idea of the shape of the distribution as well as center and spread. Yes, then you're going to find the count, which is another name for frequency, or the percent, which is another name for relative frequency, of individuals in each class. After you've created your table, your frequency table or your relative frequency table, then you're going to actually draw your histogram. So you're going to label and scale your axes, draw your histogram, make sure the heights of the bars are equal to the frequency or relative frequency. And then adjacent bars, ones that are next to each other, should be touching. That's one of the big differences between bar graphs and this one. Unless, of course, a class has no individuals in it, and then there will be a blank. So we're going to go through an example together. This one can also be found in your book, but it's good practice for you to recreate it yourselves. So this data right here is representing each state. There are 50 states here, and the percent that's listed tells you what percent of the state's population were actually born outside of the United States. Okay? So if I want to make a histogram, so what was the first step? First thing we need to do, divide it into equal classes. So you have to notice where your maximum is, where your minimum is. So you kind of scan through your data values, and it looks as though 1.2 for West Virginia is the lowest percentage, and California seems to be your highest percentage at 27.2. So as long as you make classes that go from at least 1.2 to at least 27.2, you're good to go. Now these numbers are kind of ugly. There's a lot of decimals. I probably wouldn't start my class at 1.2. Make it easy on yourself. I might start at 0. Okay? And then how you create the width is up to you. Count by something easy though. Right? So maybe count by 3s or 4s. For this example, I'm going to count by 5s. Okay? And if you'll notice, I made my first class goes from 0 to less than 5. I did that because if I just had to go till 5, and then the next class also started at 5, if there was a value that took on 5, I wouldn't know which class to place it in. Okay? And then from there, where do these numbers come from? The 20, the 13, the 9, the 5, the 2, the 1. They come from going through and ticking off all of these 50 values and putting them in their appropriate class. I know I did it right, at least from the total. There are 50 states. My count summed up to 50, so at least that's a good sign. As far as knowing I added them up right, you do have to be careful to make sure you put them in the right classes. And if you chose to do different class widths, you might have a different number of classes, so then your counts would be different, which would then lead to a different histogram. Okay? So once you have your frequency table, then you go ahead, you draw your x and your y axes. My x-axis is like a number line. Each bar begins at the beginning of each class. So 0, 5, 10, 15, 20, 25, and then it ends at 30 there. And then the heights of my bars are the counts for each of those classes. Notice how I have number of states here on my y-axis for my frequencies, and the percent of foreign-born residents is represented down here. Okay. If you wanted to make a relative frequency histogram, you basically go through the same steps. You would have to make the frequency table first, and then you would, just like we did before when we were making pie charts, you would have to divide the count by the total. So 20 divided by 50, 13 divided by 50, 9 divided by 50. So still the same classes, it's just now instead of having counts, you have percents. So if you'll notice, I'll flip back and forth kind of quickly, these graphs are identical as far as their shape. The only thing that's changed is my vertical axis. My vertical axis now represents percents as opposed to counts. But my horizontal axis is the same. The label on my horizontal axis is the same, but my label and my scale for my vertical axis has changed. So take that into account. So on your own notes, make sure you have filled in both your frequency table and your relative frequency table, and use that blank space at the bottom of your notes to make a histogram for each one. So you might need to pause the video or come back to it to make those 2 histograms. Okay, so I expect to see that on your notes, those 2 histograms. Couple words of caution for your histograms. Make sure you don't mix that up with bar graphs, y'all, right? Histogram is for quantitative data, bar graphs is for categorical data. That is huge. Huge, 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 right? Also, histograms, the bars are touching. Bar graphs, they are not. Also, don't actually use the counts as data. So if, for instance, I'm going to go back for a second. If I had this frequency table, and this is all I had, I didn't have the raw data, and I wanted to be like, oh, I wonder what the mean of this is, I wouldn't use these numbers, because it's not the actual data. It's how many numbers fall in that range. It wouldn't give me the correct answer. So, don't think of it as data. Make sure you're using percents instead of counts on your vertical axis when you're comparing 2 different distributions if they have a different number of observations. So, say for instance, I was comparing, I don't know, what's a good example? Heights of girls at Eastern Mennonite to heights of boys at Eastern Mennonite. I'm going to assume off the top of my head that they don't have the same number of boys and girls at this school. So if I were to make histograms for both, I wouldn't use just the counts. I would want to use the percents, the relative frequency, so that way I can actually compare them. Kind of like when we talked about conditional distributions. We don't just look at the raw numbers, we look at the percentages to get a better idea of how it truly compares. Last thing you need to be careful of, just because a graph looks nice doesn't mean it's necessarily a meaningful display of the data. Beware of Excel. If you were to try to make a histogram in Excel, it does not work. Their graph creator for this is terrible. So it would look kind of like a bar graph, but kind of like a histogram, and it's just a hot, hot mess. So beware of computer output, especially if it's from Excel and you're trying to do that by hand. Happy histogramming, y'all.